Today we're going to discuss a somewhat bizarre mystery coming from a nearby galaxy, NGC 4945, a pretty well-known barred spiral galaxy approximately 11 million light-years away from us that seems to contain a bizarre cosmic mystery, an object astronomers have only recently discovered, and an object that doesn't seem to fit into any astrophysical category. A bizarre enigmatic source now referred to as Punctum, a Latin word meaning dot or point, mostly because of its very compact, dot-like appearance. But because it's so bizarrely bright and because it has so many unusual features, this has now suddenly become one of the biggest mysteries in astronomy, which means that we obviously have to discuss it. And so let's talk about this a little bit more, but I guess let's first start with the galaxy itself and what we know about it so far. So first of all, as you can see from this image, this galaxy is seen almost edge-on, and it's notable for two main features in its central region. First of all, it has a lot of gas. It's heavily obscured by thick active galactic nucleus, which is of course powered by a supermassive black hole in the center, which for astronomers makes this one of the most exciting galaxies because we get to see how these black holes interact with all of the stuff around them. But it's also a site of very intense nuclear star formation, or basically starburst regions, which seem to produce a lot of stars all at once. And you can see these regions as these beautiful red formations across the galaxy. And some of these regions, especially the ones near the center, are so bright that they seem to produce at least half of the brightness or luminosity coming from this galaxy. So this galaxy is definitely quite active, and there's a lot of stuff to study here. But this new discovery was made possible by using a slightly different observation, specifically using ALMA, Atacama Large Millimeter Submillimeter Array that observes the universe in slightly different wavelengths, specifically millimeter wavelengths similar to the radio waves, allowing this telescope to pierce through most of this dust and most of this gas, and allowing us to see through all of these obscure objects into the galaxy itself. And this of course provides us with a unique perspective into a lot of activities inside the galaxy, mostly because these ALMA observations help us see the gas, the dust, but also magnetic fields in various galaxies, helping us trace the star formation or even map large-scale magnetic structures, which then helps astronomers to kind of create a map of all sorts of dynamic processes inside various galaxies. And so here, ALMA's unprecedented sensitivity and angular resolution truly transformed our ability to be able to resolve extremely small compact objects, even when looking at super small objects like black holes. For example, ALMA was able to create images of the magnetic field around the famous M87 black hole. But let's talk about this new object, Punctum, the source that was initially identified in the ALMA Band 3 observations, which usually operate around 1 GHz range. And here, despite the region being very crowded and containing a lot of objects, this object stood out quite a lot. And it seemed to be approximately 200 light-years away from the center, so this was definitely not the central black hole and not some kind of an activity related to central region, instead appearing to be completely separate. But I guess why is this strange, and what's so special about this? Well, here are some perplexing characteristics of this Punctum. First of all, as I mentioned, it's very compact. Even with ALMA's high resolution, this object seems to translate to a physical size of something like 2 parsec or just over 6 light-years in size, maybe just under 7 light-years. And this by itself is quite significant, because we don't really see a lot of objects that are so compact and so ridiculously bright. It's also very bright in certain frequencies, specifically millimeter frequencies. Considering its distance and considering what we're seeing here, this is approximately 2 × 10 to the power of 35 erg per second, or just to put this into context, it's about 100,000 times brighter than a typical magnetar, 100 times brighter than the most powerful microquasar, and here's the strange part, at least 10 to possibly 100 times brighter than a supernova remnant, with only one known supernova, Crab Nebula, surpassing it in terms of brightness and in terms of microwave luminosity. But it's not just bright, it's also kind of constant. This object has been detected across multiple epochs between approximately 2019 and 2023, and it seems to have shown no statistical significance in terms of variation, so essentially it doesn't change much, it seems to be always bright, and does not seem to be some kind of a transient or some kind of an explosion that might explain what's going on here. In other words, we have this very bright, very constant source that's brighter than any other object known to us. But since this is visible in the millimeter wavelengths, here polarization also matters. And that's because observations of polarization usually provides us with very detailed cosmological information that temperature and luminosity alone cannot provide, and that very often is caused by some kind of a magnetic source nearby. And this object exhibits an exceptionally high degree of linear polarization that seems to be about 50% on average. And this is quite rare for astrophysical sources, and suggests that the emission originates from some kind of a highly uniform ordered magnetic field source that doesn't seem to change too much. In comparison, some of the most powerful supermassive black holes, such as blazars, will usually have maximum polarization of just 15%, so whatever is happening here seems to be way more magnetized. As a matter of fact, the only thing that can explain this high polarization seems to be some kind of a very powerful synchrotron radiation, which is usually produced when a lot of charged particles move at very high velocities near the speed of light and spiral around magnetic fields, emitting radio waves. So something here could be spinning very fast and producing a lot of emissions. But I guess even more mysteriously, there seems to be no counterpart in other wavelengths. Despite being super bright in 100 GHz, Punctum has no clear counterparts in X-rays, radio waves, infrared, or optical observations. It's basically invisible in everything else except for that one wavelength. And though it is possible that it's just hidden from us because of a lot of dust here, some wavelengths, like radio light, should still be getting through. But importantly, this kind of suggests that this is very likely not a background object far away, such as some kind of a distant quasar or distant blazar, and seems to be an object inside this galaxy. And so I guess the question is, so what is Punctum? Or at least, what could it be? Well, this is where the mystery deepens. Here the astronomers compared all of the observations to known objects, or to even various known classes of objects, especially the ones emitting synchrotron radiation or producing high polarization, and nothing so far matched. None of the objects that we know produce these emissions seem to have properties that are even remotely similar to Punctum. For example, when it comes to neutron stars, such as pulsars or even magnetars, most are just too faint in the millimeter band to even be visible. Here there's actually one example, Vela pulsar, one of the brightest pulsars observed by ALMA, and is nearly 1 billion times fainter than Punctum. Likewise, magnetars, which are the highly magnetized neutron stars that often do produce high polarization, are also extremely low in millimeter luminosity and have never been seen producing anything similar. And so pulsars and neutron stars and magnetars seem to be out. Now what about some kind of a supernova remnant? Well, here we can compare this to the most powerful known to us in the Milky Way, Crab Nebula. These are of course expanding shells of gas and dust following powerful explosions of very massive stars. Now, as I mentioned, this galaxy does contain a lot of active regions and a lot of starburst activity, so supernovae here are kind of expected. And we know that objects like Crab Nebula can be also very bright in millimeter wavelengths. But the problem here lies in the polarization and the size. Crab Nebula, for example, exhibits a much lower millimeter polarization of only 7% compared to 50 observed in Punctum. Likewise, supernova remnants are usually large, extended objects, with this one being at least 11 light years across, whereas Punctum seems to be a lot more compact and a lot smaller. The other potential explanation is what's known as a microquasar. In essence, a stellar mass black hole orbiting some kind of a star that's consuming a lot of mass from its partner, producing enormous jets and a lot of brightness. But here once again the millimeter polarization is usually extremely low, despite producing very bright emissions, with additional explanations essentially being some of the least understood objects. For example, galactic filaments. Here we're talking about multiple objects discovered in the Milky Way that all seem to be kind of long, narrow, and produce certain emissions with signs of a lot of magnetism. In some cases they do actually have up to 50% polarization, consistent with Punctum. But here, even the brightest of these objects is usually much fainter in the millimeter wavelengths. These objects are actually barely visible, and we've only detected so many of them because of new sensitive telescopes. And so it's extremely unlikely to be galactic filaments or any other similar structures. And so essentially, as it stands, Punctum cannot be associated with anything known to us, highlighting its very bizarre, distinct nature. And of course suggesting that we might be looking at something entirely new, entirely different, and possibly something extreme and unusual. Or maybe this is just some kind of a typical object that's suddenly producing new emissions we never knew were possible coming from these particular objects. For example, this could still be some kind of a magnetar. Magnetar located in a peculiar environment, maybe interacting with something very dense in a neighborhood. But in a nutshell, this discovery highlights that there's still so much to learn about the universe, especially in certain wavelengths we've only recently started to explore. Although here the reason this object was even discovered was really because of extreme sensitivity from ALMA, and because of its ability to distinguish very small objects out there. But in order to unravel its true nature, we're going to need more observations and possibly in a lot of other frequencies involving a lot of other telescopes. For example, here by conducting deeper polarimetric observations with ALMA and some other radio telescopes, it could help us find certain patterns in its polarization, which might give astronomers more hints on what this is. Additionally, James Webb Space Telescope could also play a role here if it can actually identify some kind of an infrared counterpart that so far has not been detected by other telescopes. And since it is so bright in the millimeter frequency, it should be bright in some other wavelengths, and so if this is some kind of a supernova remnant or even some kind of a magnetar inside a very thick cloud, James Webb should be able to see something, allowing us to reveal its nature. For now though, this remains a compelling mystery that kind of challenges our current understanding of astrophysical objects, but also confirms that the universe still has so many more mysteries and so many unexplained objects to discover. And so until we find out what this is, or until someone else proposes something else, that's all I wanted to mention. Check out some of the other videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access and a few more things. Alternatively, you can also buy the Wonderful Person t-shirt with the James Webb as one of the designs. Stay wonderful, I'll see you tomorrow, and as always, bye bye.